Welcome viewers, in this video we will see the solved problem based on the slip of the 3-phase induction motor part 3. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the problem. For a 4-pole 3-phase 50 Hz induction motor, the ratio of stator to rotor turns is 2. On a certain load, its speed is observed to be 1455 rpm when it is connected to a 415 voltage supply. Calculate. The first one is frequency of rotor EMF in running condition, magnitude of rotor EMF at standstill, magnitude of rotor EMF at running condition. Assume a star connected stator. So first we will analyze the given data. So what are the data available? So the number of poles is given 4. Number of poles is 4. The frequency of the supply is given 50 Hz. Then ratio between number of turns, ratio between stator to rotor is 2. 2 is given as a ratio between the stator and rotor turns. The speed is 1445 rpm. The speed of the 3-phase induction motor is 1445 rpm. The voltage given V1 represents the stator, V1 equal to E1 equal to 415 voltage. In order to find the E1 per phase is 415 divided by root 3, it is 239.6 voltage. Right, it's a line voltage, this one phase voltage. First we need to find the frequency of the rotor EMF in running condition. There are two conditions available, running condition and starting condition, standstill. Right. First we need to find rotor EMF and the running condition. First we will find the synchronous speed of the induction motor, synchronous speed, Ns equal to 120 F by P, very standard formula available. Right. The frequency and number of poles is given in the problem so that you can easily calculate the synchronous speed. So Ns equal to 120 F by P, that is equal to 120 into frequency is 50, number of poles equal to 4. So by simplifying this we got 1500 rpm. Right, the motor synchronous speed of this 3-phase induction motor is 1500 rpm. Now we will calculate the slip, because the running condition, in order to find the running condition we need the value of slip. The formula for slip is Ns minus N divided by Ns, difference between synchronous speed and rotor speed divided by synchronous speed. Right. So this rotor speed is given in the problem, 1445 rpm. Synchronous speed is now calculated. So Ns minus N divided by Ns, 1500 minus 1440 divided by 1440, it gives 0.03. The slip is 0.03. Right. So synchronous speed is 1500, it is rotating at 1440. So based on that we got the slip of the induction motor is 0.03. From this slip of the induction motor we can easily able to calculate the rotor speed. So the rotor speed is rotor frequency, Fr equal to S into F. Because of running condition we need to find the frequency by using this slip of the induction motor. So this F is the frequency of the supply, S is slip. By using this S into F we will get the frequency of the rotor. So Fr equal to S into F. S is 0.03, the slip is 0.03, just now we calculated, and the frequency is 50 Hz. So by simplifying this we got 1.5 Hz. The frequency of the rotor under running condition is 1.5 Hz. Now we will find the magnitude of the rotor EMF at the stand. So at standstill this E2 divided by E1 equal to N2 divided by N1. Standstill mean at the starting. Previously what we discussed, running condition. E2 divided by E1 equal to N2 divided by N1. That is, this 2 refers the rotor, 1 refers the stator, E refers the EMF, N refers the number of turns. It is very similar to transformer. 3-phase induction motor is also called as a rotating transformer. Right. So based on that we are using this formula. So E2 divided by E1 equal to, we can write 1 by 2, because N1 by N2, the ratio of stator to rotor turns is given 2. right. So, N1 by N2 is 2 means N2 by N1 by, we can interchange, we take the reciprocal, so that is 1 by 2. So, we can replace this N2 by N1 equal to 1 by 2. So, this 1 by 2 means 0.5, E2 divided by E1 equal to 0.5. So, from this ratio we calculated 0.5. So, cross multiply this, so that E2 equal to 0.5 into E1. 0.5 into E1 is already calculated, phase value 239.6. Already the line value is given, from that we calculated the phase value, right. So, 0.5 into 239.6. So, by simplifying this, what we got, 119.8 voltage. So, the magnitude of rotor EMF under the running condition is 119.8 voltage. Now, we will find the magnitude of rotor EMF at the running condition. This one is a standstill condition. Now, we will go for running condition. The running condition very simple, E to R equal to S into E2. So, the E2 refers standstill. This E to R refers means running condition. During running condition, we need to take in the account of slip of the induction motor, because the speed decreases, that is expressed in terms of slip. So, the E2 phase is available under standstill. So, the E2 under the running condition can be easily calculated from this formula, E to R equal to S into E2. So, S is given as 0.03, 3% into E2, under standstill we calculated 119.8. So, by multiplying this we got 3.594 voltage. The magnitude of the rotor EMF under the running condition is 3.594. Now, we calculated all the parameters: frequency of the rotor under the running condition, magnitude of rotor EMF under the standstill condition and running condition. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.